Hello and welcome to another episode of Getting into Good Oxide. Welcome, Sydney.
Hi, Sebastian.
I still think I should spend some time on finding an awesome way to start a session. You know, I think this can be improved because I always end up with the same words. But today I say yes, the last one for the week, and this one, of course, is going to be special. And it's special because it's going to be short. Because it's going to be super easy to implement this. And what is it? It's this short cha here. It's this, oh look, output the 7-digit cha instead of the 40-digit. And that should be super trivial to do, right? I mean, take the 40 digits, take 7 characters, 7 bytes, and that's it. So let's just do it. Ref pass single head. This is the original code here from Git2, and then we have short ID. We'll take a look at this in a moment, but let's just naively implement this ourselves, because we should have the commit ID, well, short ID as string and then toString. That's kind of a complicated way of getting a string, by the way, you know? Like, toString you can do, and you can also do into. So there's a bunch of ways to get a string easier than what was here. But we have commit ID and then hex, 2 hex with lang. Somebody had that problem before. I think at some point I had to do something like that, so I implemented that. It wasn't easy, actually. See, into works, told you. So it wasn't, yeah, I mean, into, sometimes I ask, should I be more specific and say to owned, which doesn't work here, interestingly. Because this is something that implements display. So we always have toString. Hey, that's interesting. What's this? Yeah, it implements display, and into seems to be doing it, but not, because it's an option here. Okay. Now I understand why there was this complication here in the original code. So I think we want to do toString, and we can just do it like above for clarity, and that should be it. Okay. It's interesting. So it seems like there can be empty values apparently, or just empty strings. I don't know why there would be an option here, but maybe one day we'll find out. This should already do it. Let's see. No. Okay. It seems that my local version here is in a state that isn't great. Let's just go to something that probably works better and try again. Okay. Interesting. I would have expected the short chart to show up here, like before.
Oh, it depends on the configuration, right? What we're putting in there.
Yeah, it does. Maybe there is a bug here somewhere, normal and short. So if it matches both, then we have normal and short, otherwise just the given kind. It's just a bit strange, because I thought that whenever we put an actual variable in there, it's automatically getting printed. Yeah, look, there's just 2 Git environment variables here. And that's much better. So it looks like we genuinely don't put that in. let's make sure. Oh, this is like writing Go, really. Like the Go compiler always barks at you if there's an issue with, yeah, now you have to remove that. You know, you just want to try something. That's unreachable code. And this is Go, the Go experience for you. I did not like it. However, it gets there. So what's the deal here? Why does it not get displayed? Is this something with the test itself? Remember, I actually had problems locating the test. So I don't know. It definitely gets here. I mean, let's let it fail afterwards, just to prove it once more. Oh yeah, okay, Sharkind. Sharkind gets there. And that just outputs things to this buffer here. And definitely configures to print the short one. And oh yeah, look. And this doc test, that's the one that gets here. This is why we did not see that before. Look, it even wants to print the short one. So I would expect this to really, yeah. Okay, so we get there, but we don't get to see it. So whatever, because whatever prints this, look, whatever prints this does not seem to crash. Yeah, so this is somewhere else. This also means that we could maybe make it crash by stopping it here. So put something in that branch that creates the long SHA. So that is so whatever is happening now is not part of the plan. I wanted to talk about something more interesting. Okay. So it's still kind of hard now. Everything breaks. We still don't know where that originally was supposed to come from. And I don't know, actually. I can just assume it works. We can just do this for now, so we get to see that short hash. 1, 2, 3, 4, 5, 6, 7. So that works. But somebody definitely isn't configuring the short one, apparently. So we don't get to see it here. This means the way of testing also isn't really working that well here, because the visual testing now breaks down as we don't have visuals on this. And what happens if I search for this maybe? Do I find some test there? Yeah, that's the original code. But also doesn't do anything special. We have copied the exact logic here. So I would expect us to get in there. Okay, last thing maybe. Maybe just kind of unconditionally add that here. Once we have a commit, let's always add this key and see if it shows up in that printout here. Look, it does show up. So, but I think it really is the configuration here. The one who calls this doesn't actually configure the short SHA, and this is why we don't see it. So, yeah. I guess that's something to to live with for now.
Yeah.
Maybe one day I will figure out where that is coming from. There must be something smart you can do to know who is printing to standard error or standard out. But I mean, like this maybe. Maybe it's one of these. Maybe it's one of these doc tests. Yeah. So here, I think these must be it. But I'm also surprised that the default config is not including both. But maybe that's exactly it. The default config does not include both.
Mm-hmm.
And that's why. Can we quickly jump there somehow? And yeah, I don't know. It does have problems with IntelliSense here. Is there some git config? SHA-kind. Yeah. Default. Ah yeah, here we go. I think it's related to this. SHA-kind normal. So if I set this to both, oh yeah, so there is a test that fails. But we do see the short SHA. Okay, fine, that works. That works. Okay, so now let's have a look at what Git 2 does. Because in theory, we're done with that, even though we kind of manually put it into shape here. But that's good enough for now. But what does Git 2 do here? Git 2 has a short ID. Maybe I can also check it out here, but yeah, now we quickly go into C land. So you would have to check the code in libgit2. But let's see if there's anything written. Short abbreviated one, okay. This starts at the core abref length of 7 characters and iteratively extends to a longer string of that length is ambiguous. And what you get will always be non-ambiguous or unambiguous. And that's...
So that just means that the 7 letters, like they could be duplicated somewhere in a
Yes.
different hash. And then that's when you start, you have to map the long ones to different short ones essentially and get longer if it doesn't work out.
Yes, that's the one. That's the issue. So it's not always 7. 7 is just a good number of values that usually work. But you have to validate it. And that validation means you somehow have to give it a short ID of some length, even with 7 characters, which is like half a byte, you know, like what do you do with the other half? Do you set it to 0? Probably, but you have to deal with that. And then search through all the objects in the database and make sure there's no 2. And let's see how Git does it. I think Git does it when you invoke graph parse. So
does every long hash or normal hash automatically have to have a short version of it, or is it only kind of on demand?
It's on demand.
Mm-hmm.
So this is really a special thing only for display. Like inside of
Right.
Git, nobody works with that. Of course not. It's extra. It's overhead. You want to uniquely identify something, and that's what these hashes are for.
Mm-hmm.
So that makes sense. Git ref parse. I can parse a fully specified object into itself. I can also do this. So if you look at the code for ref parse, we should find code that deals with these abbreviations. And at some point, it should tell you that it's ambiguous, see? And that's exactly what we want to find out. And if it's ambiguous, we go higher, and now it's non-ambiguous. And that's the kind of algorithm I have to find. And of course, you could make it that short, right? But then it's likely that really quickly somebody will add an object that then makes this short one ambiguous. So this is why it starts with 7, which is still quite short. But yeah, for most repositories, there will be no collisions. And that's exactly it. Huh? It's a collision. If your hashes are too short, there will be some overlap. All right, so let's dive into Git real quick. It's also a bit of an exercise. Like, how do you figure out how Git does it? Like, what's the math or what's the computer science? And yeah, you see, this is how I do it. Like I use IntelliJ for actual work, but I use Visual Studio Code for kind of everything else and for looking at stuff. And IntelliSense is usually good enough to, do exactly what you usually want to do. So IntelliSense is great here. Okay, so refparse. Refparse is a built-in, and then just find where it kicks in, where it does the work. Here it does parsing. Not a flag argument, try parent shorthand. Get OID with context. So maybe this. So the name might be the passed in. Yeah, I think the name is what we pass in. And get OID with context, that seems to be the thing that fills in the actual object ID once it found the object based on the name. Because refparse, it calls it name because you can also do head, things like that. You can give it anything. What about the tree of the head? So refparse is literally a little language that allows you to specify all kinds. First parent, tree. Yes, there we go, right? So this is what refparse does. But it also, you can of course start with 3B09. And this is why it can do it, right? It can do this and much more. So eventually in here somewhere, there is code that deals with abbreviations. But it also has a lot of other code that deals with this.
Yeah.
But that's where it's gonna be somewhere. So maybe also look for abref or abbreviation. So maybe we can find that earlier or easier. Minimum abref, default abref, repo find unique abref. Ah yeah, so look, that's a bit like it, huh? Return abbreviator 1. Yeah, that will be at least lang characters long. So that's the function we would call. It's literally that, right? Like we give you a full OID that we have, the commit hash, and we give you a length, and you give us the shortest possible one with at least length or longer. And you do it right. So this is the function we want to understand. And it might be implemented here. No, here we call it. Let's just jump there. Then it's easier to find. Yada, yada. And then we go here. Okay, that's cool. Repo approximate object count. So that should already, that's already kind of an optimization. So approximate object count is not specific, huh? Okay. The question is, does it have false negatives? So it would tell you there's only one, even though there's more, or does it only have false positives? I don't know. So ideally, so it's always, how does it do it? Interesting. OID to hex, look at that. Oh yeah. I don't know actually how this works. This ignores. Okay, so this literally counts objects here. That's not yeah, that's not based on R is the repository. Didn't you know? It's unrelated to anything. It's really just, okay, let's figure out some object count. And based on the object count, maybe then they can optimize something here. Like this. Apparently based on the number of objects, you can know if there's like which length you can do. So that's an optimization, clearly. Interesting. But besides that, once you decide you have to look into the actual objects, then it finds abbreviation lang packed, and it uses the MAD structure, min abbreviated data. All right. I think the one who typed this acronym was doing that with a smile. I would hope so, at least, because it's worth it. Okay. Yeah, see? So if there's a multi-pack index, you have to deal with that. The good thing is if you have one, then usually most of the objects are in there. But you also have to go through all the packs that are there and then search in each index. And this min abref data, I think that just keeps track of the search so far. But you have to search everything. See, there is no I abort early. It's give me all packed objects first. And the reason it does packed objects first is that these are fastest to search. You don't want to look at loose objects at all, because if this comes up with more than one, then you know you don't have to search loose objects anymore. But if this comes up with one, then you have to search loose objects, I presume. That's how I would do it, I guess. Okay, so let's see what MAD is. Init lang, kern lang, hex. Yeah, I don't know what that means. And they don't document it. It's usually about sizes of something here. You know, this is a pointer to characters, how many. So if something can grow dynamically, maybe it's something about this hex here. So instead of having a string of some sort, right, they have a bunch of fields that count how much memory is allocated for this pointer of chars. So it's actually easier than it looks. In Rust or basically any other programming language is like, okay, fine, let's have a string here. Okay. Init object disambiguation. And what does that do? Yeah, I guess here it tries to find the right length for it, but I don't know how it then decides. So if this returns -1, something is wrong. And it totally aborts. Otherwise, it searches for the loose objects here. Find short object file name. So independently of whether I fully understand this C code or not, which I kind of don't, I don't know what they do with that length then, you know, this ambiguation. I don't know how that works, but it's clear that in order to properly implement it, you will have to use some algorithm, which we also didn't look at. Use some algorithm to search that abbreviated object in all objects within a multipack index or a normal index. And this is how they do it here. Like, yeah, see here, binary search MIDX. So they do a binary search with the short hash. And then based on the match, they have some more logic there. And the same thing you do for normal packs, where you have an index and there you see our binary search pack. And that looks probably pretty similar, except that the pack layout in memory is a bit different. So you have the different math going on, I guess. But it's the same thing. It's just ultimately a binary search, I suppose. Anyway. And yeah, once you've done that, you're nearly done. And now all you do is do the same with objects that are on disk and find files that have a certain prefix, essentially, which seems to be the most natural thing, like from what I've seen so far. And probably there you can also be smart by, yeah, you already know the prefix, so you can already skip a lot of objects that you're not interested in. That's great, because usually you have more than two. But think about it, if your abbreviation is really short, then you have to deal with that initial folder as well, like git objects. So if abbreviation length is 1, then you have to search through multiple folders. And you have to deal with that folder thing basically separately. And I think Git does that, but maybe not. I don't know. Something to check. Does Git try to implement it correctly and in full? Or does it just say, come on, an object with one length of 1, are you kidding me? Like, it could, right?
No.
It could say no. It could also say 2 is too short. It could do that. And that's maybe a shortcut, especially for this, where it really makes a difference. For the binary search in PAX, it doesn't make a difference how short your initial thing is, except that it's less likely. What's more likely that it's ambiguous, the shorter it gets. Yeah, so 3 places you have to implement this in, and that means a lot of tests. That means a lot of work, even though it's kind of the same always, but it definitely is some work to be reckoned with. And I think the most fearful I am about the loose object search here, because of the folder special case, if you choose to allow very short abbreviations. Yeah. And that's fun. It's like, yeah, it's easy, right? But no, it's not, because there's lots of special. Because Git is actually smart, kind of, or let's say correct. Git really does a great job, and we just don't appreciate it nearly enough for what it does for us. And yeah, we got to implement that, but I think we can do that next time.
Yeah, but I'm guessing there's a lot of small things that you have to, or that you will find out in the process. I'm guessing a lot of little special cases and stuff like that. Just something to do very thoroughly.
Yes.
A lot can go wrong.
Yes. It's going to be fun, though. It's probably not a big deal. This is perfect for test-driven development, and I think one we can do on camera for an index maybe or something, just index lookup of abbreviated hashes, because that seems like fun, and the rest is just work, nails in the wall. Yeah, that's
cool. Looking forward to it.
Me too. I've done that before, actually. I've done that for Git Python, I think. So we can even look at that code and see how that's implemented, because I think it's not much, but also Git Python code is not at all correct, and it's kind of very, very, it kind of works, but that's not good enough, so I probably don't look at that at all. That's the sins of the past for me. Yeah, with these words, into the weekend. Thanks for watching, and goodbye.
Bye.